So hi again. So this video, we're just going to have a look at following on from the contouring example which we completed in the last session. So to follow on from that, we've been asked to produce a long section along one of the grid lines on the plan. So referring back to the contour plan that we previously used, we had the series of intersection points. We had the reduced levels feature the points and plan view. So what I've done here is I've just kind of sketched them out on this sheet of paper, just due to the way my camera is set up. It's quite difficult to flip between what's on the computer screen and what I'm going to be doing in terms of the drawing. So what I've done is I've just basically sketched out the information from the respective grid line on the plan view. So if I just read it out just now, what's required, it says to produce a long section, which is going to be covering a 20-metre length along grid line A from the contour plan. And we're wanting to show the surface levels at 5-metre intervals from a suitable datum. So we'll come back to that in a moment. And we're wanting to show a 300mm diameter drainage pipe in the ground, laid at a grade at 1 in 100, with a minimum ground cover of 1.5 metres to the invert level. And we're also told that we've got gravel bedding of 150mm in depth below the pipe. So I'm just going back to the contour plan. So the line in question is grid line A. So if you refer back to the plan, you'll see along grid line A there's some intermediate levels being provided. So in this case, Y and Z. So that means that the spacing now in between each of the points along grid line A from point A1 to A3 is now going to be 5 metres. So what we've got here is we've got our 20-metre section of drainage that we're wanting to produce a long section of, to show how it would look in the ground. Okay, so basically in between each of these points, it's 5 metres. So if I just sketch that out here roughly just now, 5 metres, 5 metres, 5, and then 5. So that gives us a total of 20 metres from point A1 through to A3. Okay, so all this is from the contouring example which I've highlighted here on the page. So if you refer back to that, this is where you'll get these values from. Okay, 5 metres in between each point. So if we can have a look at the question again, what we're asked for. So we're told we want to produce a long section. So that's looking at a long, imagine we're to cut. So imagine this is the ground we're looking at in plan view. So imagine we dig down next to this line and we're looking at it from either the right hand side or the left hand side along this line. What is it we're actually what would you actually see in the ground? So we're just wanting to produce a visual kind of representation of what we'd see along that line. So we're told that we've got a 300mm diameter pipe. Okay, so this is, we'll just assume for the purposes of this is a drain. So again, if I just maybe sketch on here, hopefully you can see this okay. So we're told we've got a 300mm diameter pipe. So if I draw a circle here, so that's our pipe. We'll put a wall thickness on it to represent the actual thickness of the pipe material itself. Okay, so there's a rough kind of sketch of a pipe, so a cross section through a pipe. So when it comes to pipe work, there's various levels that can be provided. In our case, we're given information referring to the invert level. Okay, So the invert level on a pipe is basically the level at which the water is going to flow. So in this case, the internal bottom of the pipe. So this is what we refer to as our invert level. So invert level. Okay, so just put in there IL for invert level. Other levels which can be provided for pipe work is the top of the pipe, which is what we call the crown. So this is the crown level. Which we're not really interested in this question, but just for your information. So generally speaking, when it comes to pipe work, rather than laying the pipe directly into the soil, which it's going to be bedded into, we use what we call pipe bedding. So this is an aggregate which we use. So we dig down to a given depth. So for example, we dig down below the level of the pipe and allow for a thickness of pipe bedding to be laid. So basically we dig down below the pipe. So this is imagine this is a trench now that we've got. We're wanting to lay this pipe in the trench. This is a cross section cut through. So you've got the pipe, and then you dig it down to like your formation level. So this is the ground itself, which has been excavated down to the required level to give us the correct grade for the pipe. So then what we would do if we were to install this pipe is basically we'd fill this up then to our kind of invert level, or bed level, with this aggregate, so our pipe bedding. And this basically just gives a nice clean surface for the pipe to sit on. It's easy to work with, relatively small pieces of aggregate or stones. So basically they can be scraped down with a shovel or with an excavator bucket to the required level and grade. And then what happens is that the pipe then is bedded on top of this aggregate, so it allows it basically to sit at the correct level. So it's easier to work with, so there's no large stones protruding which could damage the pipe. So it's a kind of nice, clean, safe environment for the pipe to be situated. So basically you lay your pipe in the ground on top of this pipe bedding material, which in our case we're told is going to be 150 millimeters in depth. So I just note here 150 millimeters from the invert level to formation level. So we've got 150 millimeters of pipe bedding. And then basically to kind of finish this off, you then have your pipe bedding. Once that length of pipe has been laid to the correct level, the correct grade, you then basically surround the pipe then with some more pipe bedding in the ground. And then you would then proceed and backfill with the material that you've excavated to reinstate the trench once everything's been complete. So this is this is a cross-sectional view of what we're going to produce, just to show you what information we're going to need. So we're told in the example that we need a minimum depth of cover. So the minimum depth from the ground level, so from the existing ground level. So if I hopefully fit it on here, so we'll have ground level. Sorry, I can't spell ground. To the invert level, we're told it's got to be a minimum, in our case, of 1.5 meters. Okay, so we've got a minimum depth of cover of 1.5. So 1.5 meters is the minimum depth that it should be from our ground level to our invert level of this pipe. Okay, so to begin with then, to produce our long section, what we have to do is identify first of all the lowest point, so the lowest level reading that we've got along our line, so our grid line A. So in this case we can see that point A2 is going to be the lowest at 99.477. So I'll just highlight this one here just now in red. Okay, so 99.477 is our lowest level. So again, I'll just jot this down up here. So lowest level is 99.477. So this is basically the location at which we want to work everything from. So that's going to be our lowest point along that ground profile to give us our minimum cover level. So everything else is going to be greater than 1.5 thereafter. So we've got lowest level of that. So the next thing we need to work out is what our invert level is going to be based on this lowest level here. So our 99.477. Okay. So to do that, what we have to do is deduct our 1.5 meters from this level here, so our lowest reduced level at A2. So it's going to be 99.477, which is this here. So ground level here is 99.477. Subtract 1.5 will give us 97.977. So invert level at A2 is going to be 99.477 minus our minimum cover level, minimum cover depth, which is 1.5, which gives us 97.977. So that's our minimum invert level at that point. However, we have to bear in mind we've also got 150 millimeters of pipe bedding below that point as well. So again, so this is the minimum invert level. So then the minimum formation level then is then going to be our 97.977, so the invert level of that location, minus our 150 millimeters for our pipe bedding, which works out to be 97.827. So that's our minimum formation level. So this point here. So our minimum is going to be 97.827. Okay. So that's the minimum. That's going to be our lowest point along our long section. Okay. It's going to be the formation level at point A2. Okay. So from there, that information that we've just obtained, we've just calculated, we can then work from, so we can derive a suitable datum when it comes to producing our long section. Okay, so what we'll do now then is I'll just jump ahead now that we've got that information, and we'll start drawing out the long section now. So what I've got here is I've just produced a drawing template. So I've got a page border, I've got a title box. So in the title box, information, I've got name, maybe your class, outcome, the scale to be used, which we'll come back to in a moment. The title, so in this case I've just called it example long section, and then the date as well. So from some of the theory that we've covered in terms of contouring and sections, we identified that long sections typically have different scales. So a long section typically has a different horizontal scale to vertical scale due to basically the horizontal distance is generally much greater than the vertical difference. So in order to basically exaggerate the information that we're trying to illustrate, it's best to produce the long sections in different scales. So in this case, in this example, I've got an A4 sheet of paper. So 20 meters is our overall length. So based on this, so from A1 through to A3 is 20 meters. So to best fit my page, I think I'll use a scale of 1 to 100 for my horizontal. And then I think I'll use 1 to 50 then for my vertical. Should work in. So 1 to 50, yeah. So just make sure before I start I've got sufficient room on the page. So to begin with, we've identified that we've got a minimum formation level, 97.827. So basically what we want to ensure is that our horizontal datum line is below this value, so that everything then that we're going to draw is above our datum line. So I think what I'll do is I'll maybe start, you can start with maybe 97.5, which would be below, or 97. So I think I'll go with the 97, which will keep it kind of simple. Okay, so what I'll do is I'll just draw a horizontal line on the page here. So we're told, 1 to 100. 100. So I'm going to use the 1 to 100 scale. And I know it's 20 meters long, so if I situate the line somewhere here. So I'm just aligning it slightly more to the right because I've got some text and some values that I'm wanting to put in here on the left hand side later on as we go through this example. So I'm just going to draw that line there, 20 meters in length using my 1 to 100 scale. So 20 meters. So that's me now got my first line for the long section. So this is our datum line that we're going to use now. So 20 meters in overall length. So what I'm going to do now is I'm just going to maybe extend this slightly. In fact, I'll mark on, 1 to 100 scale again. I'll just mark on the increments. So 5, 10, 15, 20. So here we've got A1, AY, A2, AZ, and then finally A3 at the end. So that's the points that we're going to be looking at. So what I'm going to do, I'm just going to extend this line out to the left slightly. So this is our datum line, so I'm just going to establish that. So again, I'm just going to call this datum. I think we said 97. So it's datum now. So what I'm saying is this line here, I'm saying the level of this line is 97 meters. So that's our datum, which we're going to work from for our vertical distances. Okay, so what we want to do is we just go through each of the points in turn, and I'm just going to plot the height or the distance from our datum line to the reduced level of each of the respective points. So again, referring back to the contour example, the values that we were given. Starting off with A1, we've got a reduced level A1 on the ground of 100.180. So that's going to be 3.180 above our datum line. So this time using the 1 to 50 scale on the scale rule. It's going to be 3.18. So just try and keep everything square. So I'm just below the 3.2 on the 1 to 50 scale. So I'm just going to put a wee point there. And then so on, so that's A1, AY. We've got a value of 100.151. So this time it's going to be 3.15 above our datum line. Just check that one again. Sorry, just draw that one out. 5. A2, we've got 99.477. So it's going to be 2.477 above our datum line. AZ, we've got a ground level of 99.526. So this time it's going to be 2.526. So 2.526 above our datum line. And then finally A3, we've got a reduced level of 99.536. So it's going to be 2.536 above the line. So again, just using the 1 to 50 scale, let's measure that. 2.536. So I've got now established my ground profile points above my datum line. So what I'm going to do now is I'm going to first of all join the points up vertically. So I'll put that in there quite as faint as I can. So you can see them. So there's our ground profile now. So I just sketch that on. And then this last line to there. So this is our ground surface. So this is looking through the ground. This is what it looks like. Okay. So what we have here then, I'll just identify these points. So we've got point A1, we've got AY, A2, which is our lowest point, AZ, and then A3. Okay, so there's our points now. So this is the ground level. So I'll just put a wee note on here. This is the ground level. Okay, so what I'm going to do now is I'm just going to produce a small table then, just below the section that we're drawing, to basically just tabulate the information that we're going to illustrate on the drawing. So we know our datum is 97, so I'm just going to go below here somewhere. Just put a wee table in. So in here we're just going to tabulate the information that we're going to draw. So we're going to have in like the surface levels, pipe invert levels, maybe excavation level, etc. So let's see how many. So one, two, say 5. So one more. So 5. There we go. So what we'll start off with then is we'll maybe have one for ground level. To begin with, then we'll have maybe invert level. Excavation level. Could have in there datum level. And then finally we'll have depth of cover. Just to confirm that the depth of cover is greater than 1.5 at all locations. Okay, so to begin with then, we'll just populate the first row, which is ground levels. Try and draw some as neat as I can. So I'm just going to try and keep it in the centre of each of the points if possible. And the last one, I need to extend the line slightly. Just to touch this last box. Okay, so what we'll do now is we'll just populate first of all the ground level row. So in this case we know that we've got the information from the contour plan. So A1, we know the ground level is 100.180. For AY, 100.151. A2, 99.477. AZ, 99.526. And finally A3, which is 99.536. So that's we got the information there for the first row for the ground levels. So this is just confirming basically what we've drawn here for the points A1 through to A3. Okay. So then the next thing we're going to look at is the invert level for our pipe. Okay. So what we're told in the question is we're told we've got a grade of 1 in 100 for the pipe. So it's going to be flowing from A1 to A3. So the flow is going to be going this way. So we're told that we've got a grade of 1 in 100 for the pipe. So what that means is that for every 100 meters in length, we're going to have 1 meter in vertical distance. So we draw that as a triangle. So assume this is 100 meters in length. So for every 100 meters, we're either going to be going down 1 meter, or we could be going up 1 meter. So basically 1 in 100. So for every 100 meters horizontally, we're going to have 1 meter vertical.